c'est ça.
C'est bien, c'est bien. Ok, mais du coup, là, ça a changé parce que c'est un nouveau. Okay.
On a perdu les vieux.
Ouais.
Ok, c'est pas grave. Ok. Tu m'envoies les nouveaux sur Mattermost?
Oui.
C'est un micro de combat. Micro Linux.
Ouais, she sent me an email. We'll check with Francois.
Can you hear me better now?
Yes, I think we can hear you well now. Yes. And we will also is on YouTube.
I don't see you, but I see.
Yeah, I arrive, I promise. Where is the link? I just need to connect to your. So you plan to speak about 50 minutes? 45?
50, yeah, 50 minutes. Yeah.
So I will give you 50.
Yeah, it's great. Yes, I push the acknowledgements in the presentation so that it fits in the live stream as well.
You have to accept it.
Yes.
So we'll start immediately.
You did it?
Hello everybody. Hello everybody. Oh, so there is some echo. Go. It should be better now. Yes, great. So good afternoon for people in Europe. Good morning for people in US. I will act as the president of the habilitation jury for Claudio Pacchierotti. We have a very nice jury. For people who doesn't know me, I am an INRIA senior researcher here in Rennes. Claudio, you had 3 reviewers. The first one was Sandra Hirsch from TUM in München, Germany. Hello, Sandra, nice to see you. We had also Stéphane Régnier from Sorbonne University in Paris. Bonjour, Stéphane.
Bonjour, François.
We had also Abderrahmane Kedar, who is a CNRS senior researcher in both Montpellier and Tsukuba. Hello, Abder. I probably
Bonjour,
can
François.
hear you. Bonjour, Abder. Hello, we can even see you. That's wonderful.
Bonjour, François.
And we had also 3 external reviewers. So in alphabetical order, Professor Antonio Bicchi from University of Pisa.
Bonjour.
Ciao. Antonio, are you there?
Yes, bonjour. Ciao.
Bonjour. We have another Italian guy. That's a surprise. It's Domenico Praticchio from professor at the University of Siena. Nice to see you, Domenico.
Nice to see you, Francois, and all of you.
And finally, we have a colleague from Rice University in US, So Marcia O'Malley, nice to see you also.
Good to see all of you.
Wonderful. Not too early for you? It's fine?
8:30, not too bad.
Okay. So Claudio, it's up to you. I have to say that the report you had were quite positive, I could say. So we are in excellent conditions that we spent a very nice scientific moment. So you have 50 minutes to present your works.
Thank you very much. Thank you very much. And so, thank you very much for being here with us today. In the next 50 minutes, I will be talking about the research work that I carried out in the past 7 years after my PhD studies. The presentation of today is entitled Cutaneous Haptic Feedback for Robotics and Virtual Reality, which capture quite well the main topics of my research. But before going into the details of my research activities, let me first briefly summarize my research path, the very path that brought me here with you today. I started my PhD studies back in 2012, 10 years ago, at the University of Siena, working on the development of wearable cutaneous haptic interfaces as well as on the design of cutaneous haptic rendering techniques for robotic teleoperation and telemanipulation. I worked at the University of Siena, as well as the University of Pennsylvania, University of Twente, and Italian Institute of Technology. After that, I moved to Genova to become a postdoctoral researcher of the Italian Institute of Technology, where I kept working on wearable cutaneous haptics, as well as I started to work on cutaneous guidance, active constraints, and haptics for microrobotics. After 2 years as a postdoc of the IIT, I moved here in Rennes to become a permanent researcher of the CNRS, and here I had the opportunity to significantly broaden my research scope and objectives, starting to work on haptic shared control, haptics for aerial robotics, haptics for VR, ultrasound meter haptics, assistive robotics, and so on. Now, all this work have resulted in a series of contributions which I'm very proud of, that have been also well received by the community, and I'm especially proud of the recognition that our demonstrations at international conferences had, because it has shown that we are not only able to do good science, but also that our systems are able to really improve the way we interact with robotic and immersive systems. In these years, I've also been quite active in the research community, organizing conferences as well as participating to the activities of the two main professional societies in the field. And in this capacity, I've been able to foster international research collaborations, follow and guide young students and young researchers entering the field for the first time, as well as advocating for open source and open access in the field of haptics. Very well. And now, when I think about the main topics of my research, I see them very well categorized in 5 main pillars, which are also the categories I have divided my HDR manuscript in. And when I think about how we carry out research in haptics, I see it very often going in either 2 ways. Either we start from the design and development of a haptic interface and rendering technique, and then we go to test, to evaluate these devices and this technique to one or multiple high-impact applications, or we start from a need arising from one of these applications, and from this need, we design a suitable haptic interface and rendering technique able to address that need. Of course, there exists a lot of cross-fertilization among different fields with respect to the haptic technology, meaning that very often a similar device or a similar haptic rendering technique can be used to address, to benefit multiple fields of applications at the same time. And this is something very interesting that I really liked about working in the field, that enables, while working in the field of haptics, to touch so many different fields of application, so many different scenarios. This is exactly what happened to me. My work spanned from aerial robotics to microrobotics, from assistive robotics for helping people with disabilities to virtual and augmented reality. And this, of course, has also been possible because I had the great opportunity to collaborate with an amazing group of collaborators and researchers spread a bit everywhere, especially in Europe, all expert in their respective fields with whom I have worked in these years. And now I will present four families of devices, and I will show you how they have been able to touch all these different applications. The first family of devices are cutaneous haptic feedback interfaces for the fingertip, able to provide cutaneous sensations to a human user through a rigid platform placed directly in contact with the fingertip. This set of devices has been developed together with the IIT, the University of Siena, and later on also Aarhus University. Now, from now on, I'm always placing the collaborations on the top right of each slide for each specific contribution, and I'm including also the most representative publications at the end of the slide. And here, I'm showing an example of this family of devices. This one, for example, is composed of a static platform placed in contact here with the nail, housing 3 servo motors, and a mobile platform acting as the end effector placed directly in contact with the fingertip. The 3 motors are connected with the mobile platform through 3 articulated legs, enabling the motors to move the platform along 3 degrees of freedom, towards and away from the fingertip, as well as actuating the roll and pitch motions of the platform. Now, this device provides only cutaneous sensations, and we've used it especially in applications of robotic teleoperation and virtual reality interaction. In order to extend the range of sensations this device is able to provide, we also designed a finger exoskeleton to be worn on the finger, able to provide 1 degree of freedom kinesthetic sensations to this joint of the finger. And this exoskeleton was designed to be used either together with the fingertip module, as shown here on the left-hand side of the slide, or alone, as shown here in the video. And in this other video, we are seeing how this device can be used, for example, for interacting with remote environments. You can see a remote operator here interacting with a stiff object here with a force sensor, and the device, in small, is trying to replicate these remote contacts. In this case, we didn't put a finger inside the device only to highlight the motion of the device itself, but of course it should be normally worn in this way. And you can see here how the mobile platform tries to replicate the contacts at the remote environment. You can see how it tries to replicate the orientation of the stiff object with respect to the force sensor. And then we tested this device in a robot-assisted palpation experiment. At the remote side, we had a robotic manipulator equipped with a force sensor interacting with a soft tissue phantom that embed at its inside the soft tissue phantom a stiff sphere, and the task was to try to locate where the stiff sphere was hidden. In fact, it was not possible to see the stiff sphere from outside, but its presence was easy to detect if palpating the soft tissue phantom. At the local side, we have a human user wearing our device in its full configuration, 3 degrees of freedom cutaneous module and 1 degrees of freedom kinesthetic module. And using this system, the user was able to easily teleoperate the robotic manipulator. We used a Novin Falcon here attached to the device to track the position of the user, but the Falcon did not provide any additional force information. And so using this system, the user teleoperated the robot. At runtime, the force sensor relayed the contact information between the soft tissue phantom and the robot back to the user through our device. Using this information, the user was able to locate where the stiff sphere was hidden. Now, this result is quite interesting because it shows that even a simple, inexpensive device, such as this one, can provide rich, effective information to benefit a high-impact application. And this is a concept that we'll see also later on throughout the presentation. Very well, now these devices have been quite popular. We have used them in many applications, especially to interact with virtual or remote environments. However, these devices, having a rigid platform in contact with the fingertip, are not suited for interacting with environments composed both of virtual and real objects. So for this reason, we moved to another family of devices that were designed in order to be able to provide to the user rich cutaneous information while leaving the fingertip of the user free to interact with real objects, or, for example, to do something else that did not include receiving cutaneous information. An example of this family of devices is this device. We call it an H-ring interface. It is composed of a static platform placed on the back of the finger, housing two servomotors actuating an elastic belt wrapped around the finger. When the two motors move in opposite directions, the device provides a pressure to the finger, while when the two motors rotate in the same direction, the belt applies a stretch to the finger skin. Now, this device was made to be worn either at the middle phalanx or at the proximal finger phalanx of the user, enabling to leave the fingertip free to do other things, for example, to interact with real objects. And this device, of course, is particularly suited for interacting in augmented reality environments composed both of virtual and real objects. And this is a task in AR carried out using these devices. We asked a human user to wear two H-ring interfaces, one on the thumb and one on the index finger at the proximal finger phalanges, and then carry out this task that consisted in grasping two virtual objects, then moving them on top of real objects, then grasping the real objects and moving them across the table. Whenever the user interacted with the virtual objects, the H-ring devices provide the user with information regarding this grasping action, for example, regarding the stiffness of the virtual object. On the other hand, whenever the user went to grasp the real objects, the fingertips were free to directly, naturally grasp the real objects. At the same time, we also use the H-ring devices to provide the user with the additional information regarding the additional weight acting on the real objects due to the fact that we placed virtual objects on top of them. And it worked very well. Of course, the same we cannot say when we carried out the same experiment using the first family of devices, the ones having a rigid platform in contact with the fingertip. No problems, in this case, arise when the user is interacting with the virtual objects. But of course, as soon as the user goes to grasp one of the two real objects, as it is happening now in the video, of course, the fact of having a rigid platform at your fingertip, between your fingertip and the real object to grasp, severely impairs your grasping capabilities, making the task difficult to complete, or at least less comfortable. Now, when discussing these devices and these videos, I said something very interesting. I said that when interacting, when grasping the real objects, when wearing the H-ring devices at the proximal finger phalanxes, we are able to use these devices to provide the user with additional information to render the fact that two virtual objects were placed on top of the real ones. So we started to think about this idea, about the possibility of combining simple passive tangible objects and wearable haptic interfaces to alter the way we perceive the real environment. In other words, our idea was to provide additional timely cutaneous sensations through a wearable haptic interface to change how we perceive tangible object. For example, we could make a tangible object feel more or less stiff than it really is. Or we can make a tangible surface feel more or less slippery than it really is, or maybe even changing the shape, the perceived shape of a tangible object by playing on these additional cutaneous sensations provided through wearable haptic interfaces such as our H-Ring device. And let's see a bit this idea in action. For example, in this demonstrator, we asked a human user to interact in a virtual reality immersive environment here that is composed of a pump here in red that the user is asked to repeatedly press in order to inflate this beautiful colorful balloon. In the real environment, we have a tangible representation of the same pump that the user is asked to press. In this case, the pump is made of foam, is a passive object. What we would like to do is to convey the user with the sensation of actually inflating the balloon. We'd like to make the pump feel stiffer and stiffer as the user presses into it in order to convey the sensation that is really inflating the balloon. But of course we cannot dynamically change the true stiffness of the pump because it's a passive object. And so what we did, well, we asked the user to wear an H-Ring device on the proximal finger phalanx of the index finger, the same finger used to interact with the tangible pump. And by providing additional cutaneous sensations through the H-Ring interface every time that the user pressed onto the pump, we can make the pump feel stiffer and stiffer every time that the user presses into the pump, stiffer than it really is. Another approach, another use case is this one. We ask the user to palpate the abdomen of this virtual patient. In the real environment, we have a tangible representation of the abdomen of the patient made of foam, similarly as before. And again, we ask the user to wear an H-Ring interface at the proximal phalanx of the finger interacting with the tangible object. And in this way, by providing additional timely cutaneous sensations through the H-Ring device, we are able to make a small portion of the tangible object feel stiffer than the rest. For example, to simulate the presence of a cyst. And then we extended a bit this idea to other properties and effects. For example, we are able to make an object, a tangible object, feel less stiff than it really was by pre-compressing the finger skin and then releasing it at the moment of contact with the tangible object. We are also able to make a tangible surface feel more or less slippery than it really was by providing additional skin stretch sensations. To a lesser extent, we are also able to create the illusion of encountering bumps and holes on a flat, tangible surface. Now, we carried out a lot of experiments, a lot of human subjects experiments to prove that indeed this effect exists and it is possible to change in this way the perception of tangible environments. And something that was very interesting, it was that we found out that it was not so important to provide these additional sensations right at the fingertip, where the contact with the tangible object happened, but it was enough to provide these additional sensations at the middle or proximal finger phalanx of the same finger interacting with the tangible object, but not, for example, on the finger of the contralateral end. So collocation is important, but only to a certain extent. And this is great because it enabled us to leave the fingertip of the user free to naturally contact and interact with the tangible object. Very well, and also this device was quite popular. We use it in a lot of applications, especially, of course, in augmented reality applications. And this type of devices are really interesting because they are a type of haptic interfaces. They are there, ready to provide rich cutaneous sensations whenever needed, but then they are out of the way whenever you don't need them. While wearing these devices, you can interact with real environments, but you can also drink a glass of water or write on your keyboards or do anything else that does not require being provided with cutaneous sensation. So it's technology that is there when you need it and gets out of the way whenever you don't need it. It's the best type of technology. After this, we moved more recently to a third family of devices that in some way combines the best of both worlds. It is a set of wearable encounter-type haptic interfaces ready to provide a tangible contact to the human user whenever needed and be out of the way whenever not needed. This is an example of these devices. It is composed of a servo motor moving a tangible sphere in and out of contact with the user palm. It is possible to wear this device through a layer of adhesive silicone, as you can see here in the video, on the back of the palm. Very easy, very comfortable to wear. And we also equip the tangible sphere with a set of capacitive sensors in order to be able to detect when the user grasped the tangible object. And in this way, whenever the user went in a virtual environment and approached a virtual object, we move the sphere close to the user's palm, ready for contact. And when the contact finally happens, of course, the tangible spheres contact the palm. And when the user grasps the tangible sphere, we can detect this grasping action through the capacitive sensors placed on the sphere. In this way, we are able to animate the virtual end avatar to finally grasp the object in the virtual environment. And we carried out a nice use case using this device. You can see it here, the human user wearing our wearable encounter type interface while interacting with this very nice environment, playing with a dog, picking up apples, and so on. So every time that the user went to interact with one of these virtual objects, the interface moved the tangible sphere on the user hand, ready to provide this tangible contact. Now, in this case, something that is very interesting to consider is the range of virtual objects that we are able to render using a given tangible object mounted on the device. As you can see here in this experience, we are always interacting with objects whose shape and size more or less resembles those of the tangible sphere we mounted on the device. So in other words, it's an interesting question to know how different virtual objects can be with respect to the tangible object mounted on the interface. And we are still working on this device to ameliorate it, to extend the range of haptic sensations it is able to provide. For example, we are working to add vibrotactile actuators inside the tangible object to render, for example, the contacts with objects having different textures. But we should always be careful because it is not always worth to endow a haptic interface with a larger set of renderable haptic sensations. It all depends on what is worth to do. It all depends on the application, because it is not always worth to make a device, for example, more complex, heavier, or more expensive. It is important to find a compromise between complexity of the device and value it brings to a given application. Very well, and indeed, let's talk a bit about Vibrotactile Haptics, which is by far the most common type of haptic technology out there, the one that we use every day, for example, when interacting with our smartphone. And indeed, we carried out research in this topic as well, especially using a set of vibrating bracelets similar to the ones showed here. We used many different types of bracelets, changing the type, number, and placement of the robe, but this one showed here is one of our most popular designs, composed of 4 vibrating motors placed on an elastic band to be wrapped around the forearm to provide, for example, easy to understand navigational information. And among the many many work in which we use this device, I want to talk to you about two main ones, one in mobile robotics and one in telemanipulation. The first one in mobile robotics is directly linked to the experience that we have in the team in multi-robot and formation control. Indeed, when I arrived in Rennes, we started to think about how to include a human operator in a team composed of multiple mobile and ground, multiple aerial and ground mobile robots in a way that would enable the human operator to move in the same environment as the robot, to share the environment with the robots, while at the same time receiving rich information about the status of the team and of the given task, going beyond standard teleoperation of multi-robot systems, seeing the robotic part of the team as a true extension of the human operator. And so we started to research around this idea of heterogeneous human-robot teams using wearable haptics, using our vibrating bracelets, to provide the human operator with information about the status of the team. We used a decentralized connectivity maintenance algorithm to keep the team connected, which is important in order to be able to use the agents as a team, to be able to carry out tasks as a team. A team is connected if all the agents can communicate with each other, and a team is not connected, for example, if one agent is unable to communicate with the rest of the team. For example, imagine if one robot is left behind and is too far from the rest of the team to be able to communicate with them. In this small video you can see, for example, a team composed of 4 robots, with the first one, the leading robot, moving forward and the other ones following in order to ensure the connectivity of the team, in order to ensure that a certain set of sensing constraints are met. Now we are able to implement this behavior when the team is composed only of robots, because, well, we can directly go and actuate the motion of the robots. But it is a bit more difficult when it comes to include humans in the team, because, well, we cannot directly control the motion of a human. But what we can do, we can provide a human operator with 2 vibrating bracelets, and through these bracelets we can provide the human with information about the connectivity of the team. We can provide him with information about how he or she should move in order to keep the team connected. And we tested this idea in the context of search and rescue in an urban environment, carrying out a set of 3 experiments in which we considered an heterogeneous human-robot team composed of 1 human operator and a series of aerial and ground mobile robots to visit an urban map while keeping the team connected at all times. The first experiment was carried out in simulation. The team was composed of a virtual human here, 4 virtual drones and 1 virtual ground mobile robot. The motion of the human was directly controlled by a real person through a joystick, and this real person was wearing 2 vibrating bracelets at the forearm, providing him with information about how he should move in order to keep the team connected. For example, if you see here at some point, if the human moves too fast, the bracelets will let him know that he should slow down in order to avoid losing part of the team, because, for example, there is maybe one robot unable to keep with this space. And the task consisted in visiting this urban map, visiting especially a set of salient points that you can see here labeled in blue whenever they are not visited, and in green when they are visited. This is a top view. You can see the team moving here, and this is the first person view from the virtual human operator. The task is of course completed when all these salient points are visited. After that, we considered another experiment in an augmented environment. The team is again composed of 1 human, 4 drones and 1 ground mobile robot. But this time, differently than before, the human moves in a real space. You can see him here moving in this room, tracking his motion with a set of optical cameras. Now, the position of the real person in the real room is mirrored in the virtual simulated environment by the motion of this virtual human here. And the rest of the team only exists in the virtual reality, in the virtual simulated world. Also, the virtual environment is composed of one part, here delimited in green, that resembles the room in which the human moves. So, for example, of course, the human only can move in this space. But there are also other parts of the environments that only exist in the virtual environment. So, of course, only the rest of the team, which is also simulated, can visit these parts. And as before, the objective is to visit a set of salient points in the map that are labeled blue before being visited and green after being visited. And then we carried out a third and last experiment, all in a real environment. In this case, the team is composed of 1 human operator, myself, 2 drones, and 1 ground mobile robot. The task is very similar as before, visiting a space, in this case one of the rooms we have here to do this kind of experiments, and while keeping the team connected. So exactly as before, I'm wearing 2 vibrating bracelets that enable me to know how I should move in order to keep the team connected while visiting this space, while visiting these salient points in the map. In this case, we consider 3 salient points. 2 here, you can see them in red on the ground, and 1 here above ground. So again, I'm moving, going to visit all the map, while receiving information about the connectivity of the team through the bracelets, being provided with navigational information about how I should move in order to keep the team connected. It was a very interesting, yet a bit scary experiment. Very well, and now I will talk to you about the other experience in robotic telemanipulation. And this one is in the context of haptic shared control. Shared control enables to share, of course, the control of a robotic system between a human user and an autonomous controller. Now, how to divide this control depends on many factors. So, for example, the ease of use of the robotic system, the task at hand, and of course also the experience of the human operator. And in this respect, haptic feedback can be very useful because it enables to provide the human operator with information about the actions taken by the autonomous controllers in order to avoid any misunderstanding or surprises regarding how the remote robot moves. And we carried out an experience in this respect in the context of sort and segregation of nuclear waste, which was motivated by a collaborative project in which we were working. In that context, radioactive waste need to be sorted and then categorized according to its specific level of radioactivity. And so our objective was to make such a task faster and more intuitive to complete. We considered an experiment in which we had to grasp, lift, and then place in a container a set of objects having very different shapes, size, and weight. The remote environment was composed of a robotic manipulator, shown here equipped with a parallel gripper. And the environment was composed of 4 objects, having, as I said, very different shape, size, and weight, that the user had to grasp, lift, and put in this container. At the local side, we have a human user wearing a vibrating bracelet while using a standard kinesthetic haptic interface. Now, before starting the experiment, we scanned the environment using a depth camera, and using a grasping algorithm, we found a series of feasible grasping poses that you can see here in blue. Grasping poses that were ensured to lead to a stable and firm grasp. And then we designed a kinesthetic guidance technique to help the user grasping this object, to ensure that the user would always end up in one of these identified feasible grasping poses. And the guidance was conceived in a way that the force was very, very weak when the user was moving far away from the object, but got stronger and stronger as the user approached one of the objects to grasp. In this way, the user was able to freely move around in the environment, to choose, for example, which object to grasp or from which side to grasp an object. Then he simply had to move the gripper down towards that object, and the guidance, getting stronger and stronger, would guide him towards one of these feasible grasping poses. And at the same time, the vibrating bracelet was used to provide the user with information about possibly dangerous configuration of the system. For example, we used it to provide the user with information about the vicinity of singular configuration of the system, as well as the vicinity to workspace limits. Oh. Very well. I would like to, so I talk about a lot of things, but there is a lot more going on. We are very active, we do a lot of great research, I'm very happy, and I would like to very briefly mention some other projects that I'm very proud of. For example, we are working a lot now on ultrasound media haptics for interaction with virtual reality together with Maud Marshall. We are working more and more on haptics for assistive robotics together with Marie Babel and Maud Marshall. We recently got a quite large funding by INRIA to design a multisensory haptic handle for helping people with disabilities in using mobility aids such as power wheelchair, white canes, and walkers. I'm also working on haptic guidance for helping the insertion of flexible needles in soft tissues with Alexandre Krupa in the team and Sartak Misra at the University of Twente. Together with Paolo Robuffo Giordano, we are still working quite a lot on shared control, both for industrial telemanipulation and medical robotics. For example, here you can see a haptic shared control for carrying out a cutting task. I'm also working quite a lot together with Katrin Kuchenbecker at the Max Planck Institute for Intelligent Systems on cutaneous rendering for medical robotics and personalized haptics. Very well. Now, I would like to dedicate the last part of the presentation to a bit the perspectives of my research. So every time that somebody asks me, what is next in your research, what is next in the field of haptics, well, of course, it is very hard to answer, but I like to start from two main considerations. The first one is that haptics is very important. Haptics is paramount for how we interact with our surrounding environment. Haptics is paramount for how we interact with the people around us. And when talking about this topic, I always love to show this picture that I find very representative as well as very touching. This has been taken in a retirement home in northern Italy during the COVID pandemic, in one of the places that have been hit the earliest and the most in the whole Europe from COVID. So the management of this retirement home decided to install these COVID-safe meeting rooms in order to enable the elderly guests to physically, haptically interact with their loved ones, because haptic is important. And while we all agree on this topic, unfortunately we also have to witness the fact that haptics is missing from most robotics, remote, and virtual application. And this severely limits how we interact with these environments and technologies, changing how we behave, how we interact with remote and virtual reality environments with respect to how we would interact and behave if we could directly touch or interact with them. So it is very important to keep pushing, to be working on this topic, to endow all remote robotic and virtual reality applications with the possibility of haptic interaction. And I think it is very important to especially study and find those applications that nowadays do not exist in a remote or virtual form because of the lack of that, because they cannot exist without the haptic component. Another consideration is that it is not always true that more haptics is better. Meaning that it's not always true that employing more complex, more expensive haptic interfaces always lead to a better interaction for the user. And this has been a bit our motto throughout all these years working on Cutaneous haptics. We have shown, we have proven that even simple, inexpensive Cutaneous haptic interfaces can make a difference, can be very effective in providing rich information even in high impact applications such as, for example, medical robotics. So it is important to study what are the most salient parts of the haptic interaction that are most important for each target application, and then go and focus on designing haptic interfaces and haptic rendering techniques eliciting those sensations. Very well. Now I would like to dedicate the very end of the presentation to something very important, which is thanking all the people that have worked with me throughout all these years, all the colleagues all over the world. Here I put a list of the places where my co-authors are. Nothing would have been possible without, of course, the amazing help of this group of people. And I would like to especially thank Domenico for having introduced me to the beautiful world that is the world of haptics when I was only a freshman at the University of Siena. Would like also to thank Sartak and Katrin for always helping me throughout all these years, for welcoming me in their labs when I was only a student. I would like to thank Paolo and Francois for having welcomed me in their teams, Lagadik first and now Rainbow. So I think that my integration has worked very well. I'm always very proud to say that I have been able to collaborate with the great majority of the members in the team. And so I would like to thank all the permanent members in the Rainbow team, and especially I want to mention Maud and Marie, with whom I am working every day to push haptics from within Rainbow. Also would like to thank the people at Irisa, especially those in the team Hybrid, Mimetic and Virtus, for working with me all these years. It's 5 years I'm now here at Irisa. And a special thank also to the member of the committee for having read the report and for being here today, for being part of this important point in my career. Would like also to mention all the funding bodies. Nothing would have been, of course, possible without them, especially because they have enabled us to hire an amazing group of PhD students, postdocs, engineers, and interns. Special thanks to the CNRS for having believed in me when I was only a young postdoc. Finally, I would like to thank my friends and family, especially my parents. They are following the YouTube stream, although they are not able to understand English, so I added a small part in my presentation so they know that I'm talking about them in this moment. All my friends, of course, for having helped and supported me throughout all these years. And I would like to end by thanking Maria-Elisa for sharing her life with me and putting up with all the evenings, weekends that I had to work for following this or that deadline. Last slide, I added a very nice hand-shaped word cloud with all the names of the co-authors. So the size, the font size depends on how many papers. So we can see Domenico very present in the word cloud. And this is the end. I'm ready to take any questions you might have.
Yeah, thank you, Claudio. It was very nice. You have been perfect in time. probably it was difficult for you to be seated during all your talk, because I know that you like to speak with your hands, but also with all your body,
Yeah, it
as
is.
many Italian guys.
Yeah.
So thank you again. So we will start by now with the discussion, with the comments and questions by the jury members. So a classical criterion is to use the distance. And I think that Abderrahman, who is currently in Algeria, is farthest.
There is Marsha in the US. But
Yeah, but of course we have to start by we'll start by the reviewers. So Abderrahman, if it's fine for you, I would like you to be the first to comment and ask a question to Claudio. Please.
Yeah, thank you very much, François. Thank you very much, Claudio, for inviting me to your habilitation. And I first really enjoyed reading.
There, on a des problèmes.
Yes.
There we were not able to hear you for 30 seconds.
Okay, sorry. Maybe I will stop the video because
Yeah.
my connection is not good.
Yeah.
So I was just starting by thanking very much Claudio and you for inviting me to your jury. Thanks a lot for this presentation, which was an excellent summary of your amazing work in the domain of haptics. I was really surprised by the quantity and the quality of the work that you have been achieving since all these years, starting, of course, in Italy and then in France. So congratulations really for this achievement. Because of the current circumstances, I would not ask you several questions, but I would really love to come back to you, and I will be back to France to chat with you and discuss with you about several aspects of your work. As I said, for me, it's a complete work for a person who clearly deserves a habilitation to drive research. So you have supervised several students. You have really taken them into very innovative and very interesting topics for the main domain of the haptics and its application. I liked the way you have conducted your research, starting from sometimes application-driven domain and also digging into extremely hard technological problems in making novel and innovative designs for different way to provide haptic information. As you mentioned, it's a very important modality for in-human interaction and also in conveying all what we're doing on a daily basis. So my question is really not really technical, because I have really enjoyed a lot of what I have read, and I discovered many new ideas thanks to what you have achieved. The point for me is the following. I have the impression that haptics has reached like a steady state. I mean, at the beginning, it was really very intense in the terms of innovation and in terms of ideas and in terms of bringing new knowledge and understanding this modality, both on the scientific aspect and also the psychophysics, and also in the design of the interfaces that are able to provide haptic feedback to the users. But if I compare haptics to what have been achieved in vision and in 3D sound, for instance, I still have this large gap that was like more than 10 years ago. I have the impression that haptics cannot catch up with the same level of achievement as we do for vision display and sound, 3D sound display. So in your opinion, do you share with me this fact that maybe we have reached a steady state and we need to think about a real breakthrough to allow, for instance, general purpose haptics to be designed? Or is it like physics is not helping a lot and we cannot do much better than what we are doing now?
No, for sure, like it's a difficult problem also because our sense of touch is distributed throughout all our bodies. It's really multifaceted, so it's very hard to to design one device able to elicit properly all the haptic sensation needed. But I don't think this is the right way. In the sense, I think it is better to study, to understand which are the salient parts of a haptic interaction that are most important for each specific application. Maybe we will end up with one device per application, so that we can focus on eliciting those very important parts of the haptic interaction. So achieving these with simpler devices, because of course otherwise it is impossible. But it is not true that I think we reached a point where we do not go forward too much anymore. In the recent past, we have had a lot of new technologies coming out. For example, ultrasound mirror haptics, something that it's at the end quite recent. Also, all the possibility with wearable haptics, with all the motors and sensors becoming smaller and smaller, has enabled to really achieve very good results in high impact application. Imagine medical robotics with devices that nowadays are very cheap, very easy to build and wear. So what we have done is a bit a true testament to this. We started to design those devices also because we believed in them, but also because back in Siena in the IIT we didn't have a lot of experience and expertise in mechanical design. So we started to work with something that we understood well. And then from there we realized that actually it was working very well. And I believe that if you consider wearable haptics, if you consider all the industry getting more and more into haptics, for mentioning, for example, Meta, but many others, I think, because you mute both of you. Yes. No, I saw Francois muting my microphone. They are the same. And no, I was saying that, you know, all the industry interest that we are seeing now, I do believe that we can achieve something in the next 10 years. Of course, I think we need a lot of help from perception side. So we need to study what is important and then go to design devices that elicit only those important parts, leaving out the rest.
So thanks a lot. Thanks a lot for this convincing answer. My other point is the last question, in fact, would be so that I give the stage for my colleagues also to ask further questions. Is the difficult application for this mapping, okay, when you would like to control several kind of robots and several kind of systems that you have also, and you want to use haptics for a form of feedback that substitutes something which is not easy to guess, okay, because you have a multitude of possibilities when you try to map something that is not by nature haptics into an information which is of force or tactile or vibrations. So basically, you are not sensing this vibration that you are transmitting. You are transmitting information of a different sort, like for instance, how the system is connected, whether the system is balanced or not, and you try to use haptics for that, for conveying part of this information, so that normally you expect from the user to do the right gesture, the right command, so that the things works perfectly well. So in your application, for instance, you have selected Vibrotactile, you have placed this Vibrotactile on the arms. So why this particular placement? Why this particular technology? What kind of information you are mapping, and what makes you, is there a way to formulate this so that, for instance, we say, okay, if we place this exactly at this position, if we place a certain number of actuators that vibrate at this frequency, so we have reached an optimal way to control the system.
In our case, we use that because, so it was necessary to have, of course, a wearable approach because the user was asked to move around, right? Now, once we have a bracelet, then of course we could include in the bracelet different type of actuators. We used, in our case, vibration simply because it was very easy, very comfortable to use, and we only needed to provide navigational information. So for that, vibrations are perfect. But it's true that if you want to provide more and more information regarding the status of the team and of the task, for example, we need to probably extend the range of sensations we provide in order to enable the user to differentiate among them, right? We can not provide multiple pieces of information through the same channel. Now, it would be best, of course, to have a general approach. So given I thought a lot about it, given a given applications or environment that you need to interact with, then being able to automatically know how to place your actuators, which actuators to use, and so on. I think we are very far from this. Nowadays, what happens, we rely on the experience of expert users, expert researchers that know in their experience what works best in each different application. Then we test that choice, maybe we test multiple choices to see which one is the best in that specific application, but we lack of an approach, a generalized approach to decide what is best from the haptics point of view for a given task or to interact with a given environment.
And I have others that come in the course of the discussion. I would be so congratulations again, and thank you for your work and for inviting us here.
Thank you, Abder. So, Sandra, are you ready to discuss with Claudio?
Yes. First of all, also, thank you very much for inviting me to the committee. I was really impressed by your report, HDR, showing really a huge wealth of different designs and applications, including control designs in terms for wearable haptics. So that was really impressive. Thank you for that. Yeah, maybe my questions that I would have, and more general case, go a little bit into the same direction as Abder already started. So you have like this very nice application-driven approach, and it's not only regarding what haptic information. So I'm also thinking about what could be guidelines and what would be the essential steps to get such guidelines. How to, for example, in your shared control examples, how to design the different tasks that are most suitable to be conveyed through haptic information, but also in terms of the different device categories you mentioned. What are guidelines, or what is the route? So I mean, you mentioned already that there's still a quite open field. What would be in your view the route to get to such systematic guidelines, having an application and then kind of automatically having like a design of the task distribution between maybe autonomy and so on, and also getting the right haptic devices into place. So maybe I'm asking more for your ideas how to get there.
Mm-hmm. Yes, this is very challenging, and this is something that, of course, would be incredibly beneficial to the field and to all these applications. I believe that we know, of course, that some types of feedbacks are better to provide some kind of information. And we also know that, of course, for example, vibrations are very good. Distributed vibrations are good at providing navigational information, and kinesthetic sensations are very good at providing contact interactions and so on. So we have some rules, some guidance in the sense that they come from our experience, and experience, not personal experience of the field. All this works on perceptions and on applications, showing what worked best in all the different applications and scenarios considered. Now, from all this body of work, we should try to come up with some guidelines, some general ideas, so that's like a manual on what you have to do and to do what you need to have this kind of sensations provided in this way. Now, how to get there? I think a good approach could be to for a small series of applications to try to identify which are the main pieces of information that we need to provide, and then try to see in the literature what are the best types of haptic sensations or haptic rendering techniques for delivering those set of informations. And from there on, I think there is a way to go forward and to write a bit this manual on how to design haptics for your application, for your scenario. But I never seen anything in this way. It's something very challenging, but also very inspiring, in the sense that, of course, nowadays we only proceed by trial. So we try something, we see if it works. But we don't have a way to analytically devise, for example, the best type of haptic interface, the best level of haptic feedback to make an application successful.
So what would you think? I mean, you mentioned already, you said what is best. Do you have any ideas how to we look into different applications, right? So of course, in each application, you would have a performance measure that you could have like a baseline without haptic device, wearable, and then some kind of evaluation.
Yeah.
Do you have anything that could be more, let's say, common in terms of evaluation? Going a bit into like, I say intuitive interaction. But of course, this is a very seamless interaction. So that is a bit less is application specific. But do you have any ideas how to evaluate haptic devices and interaction on a more common fundamental?
That is very interesting when working on this field, is that there is always a human, somewhere. So an approach could be to start, because the human is always the same, while the application and the systems and the tasks are always very, very, very different. But if we can focus maybe on what the human needs, so what is best for the human operator, then we can maybe try to find something that we can use. In the sense, what is best for a human to receive does not change too much, regardless of the application at hand. Regardless it doesn't matter too much if you are controlling a remote drone, a remote manipulator, or a remote medical robot. At the local side, you will always have a human operator that has two hands, has a sense of touch, and can receive, can process a certain number of information. So a good approach, in my opinion, could be to start from studying the human perception, studying how humans can receive these different types of haptic sensation. Then once we know that, I think it can be easy to then adapt for each different scenarios. I don't think it's possible to have an exhaustive guide on how to use haptic in every possible scenario, since it's of course impossible, because then for each scenario you also have different tasks, and for each task you have different measures of performance. The only thing that does not change is the fact that you have a human at the local side. So a good approach could be to study more how humans receive haptic feedback, and maybe there we can find something useful for designing these applications and interfaces.
And would you think that the common psychophysical measures are already enough? I mean, there's a lot of, like psychophysical studies, or would you think you have to go beyond that? What's missing?
I mean, we do already have a lot of knowledge about perception, but of course, with respect to the sense of touch, there is always a lot more to do. A lot of more, for example, haptic technology that have not been studied from a perceptual point of view. New, maybe even type of interactions. Imagine interactions in immersive environments that can change the way humans perceive, for example, haptic feedback and haptic sensation. So so I think we need to go forward in the sense that there are new technologies that might change the way humans perceive haptic sensation and haptic feedback. And so we need a bit to update our knowledge to fit to these new applications and scenarios.
Okay, Now, maybe one last question. So where do you see, I mean, you promoted a lot the wearable haptics. Where would you see the limits? I mean, obviously,
Sorry,
the limitation.
The limits.
Limitation. So,
The main limitation
limitations do you see? I mean, there are multiple limitations, I guess. So maybe you can order them into classes.
there are many limitations, unfortunately. Of course, for example, the need of you need motors every time you want to actuate a new degree of freedom, which makes devices heavier, more complex, more expensive, and also need, for example, of more power. So this is a limit that every time we are encountering. So we really need to select the minimum number of degrees of freedom and haptic sensation needed for a specific applications to minimize the complexity of the device. So I believe in this respect is a bit of a technological limitation, because if you would have incredibly small actuators and incredibly that consume very little, of course we could really achieve truly distributed devices that are able to provide a lot of different haptic sensations in a very small package. Yeah, so I think this is what we encountered until now, and we are working always to study in each different application what is most important, so that we can remove that motor, we can remove that sensor, we can use a smaller battery, and so on.
So in your feeling, it's mostly technological, I mean, the kind of power, mass.
Yeah, maybe
robotic issue.
Yeah, maybe as soon as we have solved the technological issue, we'll find the next one. But I do believe that right now it's really mostly a technological issue, because we could have really seamless interface that you can really wear as a glove, like really as a very thin glove that could enable you to even touch across it. That would be a huge improvement for the field. And I would say that if we would have that, I think we would have been very close to achieve what Abder was saying before. We would get much closer to what we have nowadays with video and audio technologies.
Thank you very much. But excellent.
Thank you,
Excellent report. Excellent work. Thank you.
Okay, thank you very much, Sandra. So please, Stéphane.
Thank you very much, François. First of all, I would like to thank Claudio, Paolo, and François for this invitation. Also, I would like to congratulate Domenico for the presentation, excellent presentation. After the reading of the report and now after the presentation, I can say that he has mature research profile, and his research activities contain all the elements expected to obtain the habilitation to supervise research. So it's very impressive. He masters all the aspects of haptic sciences with innovative approaches, with diversity of subject, of application. The list of contribution is very long, with also a lot of scientific collaboration and a deep involvement in the community. I was member of his recruiting committee at ERISA, and I was already impressed by his maturity during his presentation. And I am now very happy, very happy about how he successfully implemented his research at in the now Rainbow team. It's really impressive. I don't have specific question, but I would like to come back to the question raised by Abder about the application. So if I have understood your answer, you said that for you 10 years is maybe a target for application, but and also you mentioned that for you the only option is to design specific devices and specific feedback for specific application, if I can summarize like that. But do you really think it's 10 years now, or we can achieve more? Do you think cutaneous interfaces are not enough mature to revolutionize how we can interact with the virtual or remote environment? Do you think for virtual reality we cannot achieve before 10 years that?
Talk about haptics, it's a very broad range because we use haptics every day. Yeah, we could use haptics every day with our phones, for example, right? And nowadays, in all the the handles that you use in VR, they all have vibrating motors inside. So haptics is there already. But let's say it's not the same haptics that usually I'm talking about, right? So we talk about haptics in VR, we talk about of a more rich and comprehensive sensation. So what we have demonstrated, haptics for VR is there today. Now, what I think we might have in 10 years are devices in every home. So I think that especially with the involvement of big companies and that now we are starting to understand that it's truly a value to have haptic interaction in remote and virtual environment. And so pushing through the technology, being able to achieve less expensive and more compact designs, I believe that that is a reasonable time frame for seeing rich haptics, let's say, in our homes. I do believe that anyway it's important to, so it's always about between technology and the complexity of the system. So if the technology will enable us to design small devices, we can include more type of haptic actuators, so to provide a broader and richer sensation. But if the technology is like it is nowadays, of course it is important to understand what is important in the haptic interaction and try to focus on delivering that sensation. In some way, we will probably end up to have specialized haptic interface for certain application, maybe, because we are unable, as of today, to achieve a general purpose haptic interface that can be used for interacting with anything. Of course, a vibrating bracelet can be driven to render sensations in different applications, but we want to go a bit forward to really interact with forces at your fingertips and so on. I think we need a bit more, at least for the technological point of view. And a way to avoid a bit these issues is to push on perceptual studies, to understand what is important, and then focus on designing haptic devices and haptic rendering techniques that can elicit that specific sensation, at least for now. Then maybe in a few years, when the technology will be ready, it won't be so important anymore.
Okay, thank you very much. My second question is about my field of research, is about microrobotics. So at the beginning of your career, when you were a postdoc with Domenico also, and with collaboration with Professor Misra, you were very involved in haptic feedback for microrobotic. Okay, so now maybe after I don't know, I don't remember, but after maybe 6 years of not doing doing research in haptic for microrobotic, can you give me the feeling you have about this kind of application or maybe the application of microsurgery or application in the micro world, I will say?
Yeah, I loved working in that field, although it's very far from what I always said. But it was great to collaborate with Sartak and also with other people. So from my side, that was a nice experience, and it showed also that whenever you teleoperate something, it is not so important what is on the other side. You can have a drone, you can have a micro robot. So my focus was always been on how to best design an interaction between the remote world, can be macro or micro, with respect to the human. So in that respect, of course, when talking about microrobotics, you have a lot of issues because you have sensing problems, you have actuation problems. So it was very challenging and very inspiring to try to understand what kind of information we can take from these robots, for example, using vision or using other means, because it's not always possible to put a force sensor, of course, in the micro robot, and then take this information back to the user through haptics. So it was challenging in the sense that provided me with a really new broad range of problems that I did not encounter when working in Siena with robotic manipulators. So it was very inspiring in that sense. And I hope to be able to work soon in this topic again, because I think we carried out
I hope so.
yeah, and we carried out good research there, and I think there is a lot to do because there are a lot of things that nowadays are available for robotic teleoperation and multi-robot systems that could be used also at the micro scale, of course. Yeah.
If you come into we have new application, I would like to show you
Fantastic. Very well. I will come for sure.
Just for visit, we want Claudio to stay in Rennes.
Of course. Thank you very much again. Congratulations, Claudio. It's very impressive.
Okay, thank you, Stéphane. So it's now the turn of the external examiner. So, Marcia, you win in terms of distance from Rennes. So it's up to you. We have time. So feel free to ask any question.
Great. Well, first, again, I want to just thank all of you for the opportunity to be part of this. Claudio, it's always fun to hear you present your work, and today was no exception. I really wish I was there in France in person and not here freezing in Texas. So my question for you is really just to gain your insight on a particular challenge of wearables for conveying kinesthetic feedback. So you are one of the few maybe brave researchers who are designing kinesthetic feedback devices that are body mounted, body worn. And one of the challenges that I am aware of and have a little bit of experience in is the issue of grounding, right? So with a desktop haptic device, all the reaction forces are grounded, and we get this really nice salient kinesthetic cue. But when you're body mounted, you have the challenges of those reaction forces being transmitted to the limb upon which you're trying to convey forces. So I wonder if you could speak a little bit generally about the challenge of grounding wearable devices that provide kinesthetic feedback. And then my follow-up, I'll give you a preview so if you want to use this as part of your answer. Have your approaches evolved over time? And maybe I'm looking to learn from your experiences as well.
Yes, so it's a problem also for our cutaneous devices, because of course, for example, at the fingertip, you want to feel the force at your fingertip. You don't want to feel something that squeeze your whole finger, right? So this is something that we thought about a lot. So our approach was to make the grounding larger than the end effector, because in this way the reaction force is spread across a larger area. Another approach is to put the grounding on a part of the body that is less sensitive. So for example, in the case of the cutaneous fingertip devices, we had a large static platform on the nail, and then you have a smaller mobile platform that acted as the end effector directly in contact with the fingertip. And in this way, indeed, we didn't feel too much the fact that the device at the end, what it does, it squeezes your fingertip, but the resulting perception was that you were applying a force only at the fingertip. And a bit the same with the other. If you can try to spread the reaction force over a larger area, or try to somehow mask this force through some garments or putting it on an area less sensitive of the body, I think this could be a good approach, or at least a good way to start.
Right. Thank you. I'll do one follow-up question. I really like the direction you're going with the augmented environments, where you're interacting with a tangible object and using the wearable feedback to sort of modulate the perception or the perceived interaction forces for the user. And I think one of the advantages, or not an advantage, but an approach that we saw quite successful in the early days of haptic devices was the fact that we can sort of fool the user with some visual feedback that conveys the experience we want them to have, even if the physical experience is different. So, with a stylus-based device, right, we show the tip of the stylus in one location in the virtual rendering, even though the actual stylus might maybe deflecting into the object because we can't display something infinitely stiff. So, as you've been moving into this AR space with tangible objects, I wonder, to what extent can we really convince people that their tactile interactions with objects are different, or get them to perceive them to be different than the physical interaction they're actually having. So maybe how push this, and what might be some futuristic strategies?
How different, let's say, the tangible sensation can be with respect to what you see. But also, using this augmented haptic approach, let's say, of course, I was saying that we can make a tangible object feel stiffer than it really is, but of course to a certain extent. If it is a foam, it will never feel like a table, right? So to be very interesting to see what is the limit, what we can do. I guess that the limit also depends on for example, on the haptic interface that you use to provide this augmented sensation. And visually, I do believe you can fool quite much. So there are a lot of examples, for example, in pseudo-haptics, of being able to elicit haptic sensations only through changing visually here and there the environment. So this is a true testament of the importance that also vision has in our interacting with the environment. So we can absolutely use vision to fool the user, and maybe what I would like to say is that we could use it, for example, to address the limitations that we have in wearable haptics. So we know that wearable haptic interfaces can only provide a very limited set of forces. Maybe we could try to use vision to help whenever we are reaching, for example, the workspace limit or the peak force limit of the wearable device, to try to justify visually why we are not able to reach to provide that very complete sensation that the user might expect. So this I would like a lot, trying to use the other senses to compensate for the lack of haptic technology that we have nowadays.
Right. Well, I'll stop there so that the other members of the committee have time. Claudio, congratulations on a great body of work so far. Can't wait to see what you're
Thank you very
up to
much.
next.
Thank you very much.
Thank you, Marcia. So Siena is further than Pisa, but Domenico, since you know so well Claudio, I would like that Antonio gives this comment, if you both agree.
Sure.
Antonio?
Yes, of course. Yeah, sure. I will echo all my colleagues in saying that this was a pleasure to listen to. It's a pleasure to be with all of you. I really wish we were in Rennes really today. It's such a treat to see all of you there, and have a toast at Claudio's habilitation tonight, but we can't, and we have to discuss. So Claudio, I will spend very little time in congratulating with you, because everybody has been doing that, and I would just repeat, it's great work in these 7 years since the PhD. Very convincing, very focused. I guess you have done something else, but you kept one topic in this habilitation dissertation. That is great. So I was trying to make a picture in my mind of what is the path that you have been doing and where it is going in the future. And I might be wrong, but I would say that, at least from reading the presentations, and then it seems to me that you have moved a little bit from the beginning, where you had more attention to the development of hardware, to more of the applications of these interfaces. I might be wrong, because I've seen that you have recent work on mid-air ultrasound devices, which are a new direction, I would say. But I've seen a lot of attention on the applications, which I think is very good, because it goes beyond the mere design or mere engineering and deals with the demonstration of potential use. In this, if I look at your habilitation thesis, you have one chapter on devices and 5 or 6 chapters on different applications. So connected to this, I would like to ask whether you ever considered prosthetics, because that is something where I found haptics are very, very important. It's of huge momentum. If you look at how the control, the motor control of our arms and hands work, you find that out of the 350,000 nerve fibers in our arm and hand that go to our hand, 90% are sensory and only 10% are motor. Which means that haptics, all that information is, so important. So I believe that that is a good source of information. So my question is this at some point will you also look into application? There is, if you spend time with Stéphane in Paris, you will find also very strong groups there doing very nice prosthetics. So just have a look there too.
Yeah, worked in this field of application, not because simply because I didn't have the chance. So very often, I find applications in the way that I find people to collaborate with. Then from this collaboration, I go and apply haptics there. This is also why, for example, since I arrived here, I'm working way more in virtual and augmented reality, which is a topic that before we didn't touch very much. Because here I found a great group of people working in this field. But I do believe that prosthetics is a great field for the application of haptics, and something where we can really make a difference. But it is true that I never had the chance until now, and I would love then to why not also start to work in this topic. When I was back in IIT, I talked at length with Sasha, which was a researcher in your group, about this topic, and it is definitely very inspiring. But it's true that as of today, I never worked on it, but I hope to be able to start maybe working on this topic as well in the near future, using, why not, our wearable interfaces that we have developed.
A related question. So, well, you didn't answer to the fact whether your direction is more towards application or more to device.
Yes, you're right. Yeah. No, it is true that since here we're working a bit less on the design of mechanical device itself, although we did design, because, for example, the wearable encounter type interface, it is a device that we designed here. Now I'm working also more on rendering of algorithmic rendering of haptic interfaces, of haptic flows, optic data. I worked more and more on applications simply because I had the opportunity to work on very interesting and high impact applications. So I took the chance of working with all these great people that are expert in all these fields. And so I tried to also somehow a bit capitalize our set of devices and experience in rendering techniques that we have to go and try them in all these different fields of applications. But it's not that I definitely moved towards applications. I'm always open to design new interfaces. For example, as I was mentioning, the encounter type device, it's something that we are working on it right now. We are now writing a paper to submit in next month, so it's still very, very active. Maybe another thing is that here at IRISA we are not as we are not super expert in Siena in mechanical design, so it's not something that that we are doing, let's say, every day. We are more working on algorithmic, on rendering techniques, and on applications, as I was mentioning. But me, I'm always open and happy to work a bit on everything. And it's not that we finished, let's say, our path in developing devices that then moved to applications. It was simply an opportunity to work on different fields. And for me, I find it also very motivating to find a new different field to apply haptics to. So very often I jump on, or maybe on too many opportunities to apply haptics here and there. So since I arrived here, we applied it in, as I said, in VR, but also in a crowd simulation, in many applications that I never even considered before coming here. And it's been really exciting.
Okay. Then I have a question that is more detailed. So you had us in slide, around slide 30 or so, you were describing an application where you use feedback for, yes, like here, for leading, for driving a team of robots. And you say that you are using this haptic feedback to basically tell the person whether he was going too fast or too slow, and whether, and this implying that a connection could be lost. So this was, of course, you had very limited time, but I was a little bit unclear on what's the how does it work, if there is more that you do than just a slower, faster command, and if there is more, how long does it take for the human to learn operations through this tactile interface? And another question is, why not vision? Why tactile to do this? I mean, would be enough to have in your display like a bar that says, or just slower, faster, or something like that. Did you compare the value, the added value from tactile?
So in this case, so slower or faster was an example. So actually the information we provided was more complex. We provided really a direction to go, a direction with a magnitude, let's say. So we are really guiding the user along towards a direction that ensured that the connectivity of the team was maintained. It's true that we could have provided the same information, for example, through vision with some kind of augmented reality glasses, for example. But I do believe that we use vision a lot. And maybe the user wants to do something else than regarding an arrow moving left and right. In this case, for providing navigational information, haptics is perfect. So why we should not use underused and underexploited channel, such as the haptic channel, and we should use the visual one. So this was more like a choice of convenience. So we are not using our haptic channel, let's use for this, so that then the user, the vision of the user, can be focused in doing something else. Of course, in this scenario, the something else was nothing, so there was nothing else to do. But in another scenario, for example, in search and rescue, it might be important that the user vision is focused in looking around for finding survivors or for doing anything else than being focused on looking at visual information regarding the connectivity of the team.
Okay, in this regard, I think the question you said during your discussion before that the real question is to see how much complexity you add and how much you get out of the added complexity in order to justify that. So I really think that at the end of the day, issue is usability. How usable is the system? How do you use the usability of these interfaces throughout all your application? So is this dimension of usability something important for you? Do you use those tools, or do you plan to use those tools in the future?
Definitely, and this is why also we have chosen vibration, because it's very easy. So you have two bracelets, so turn left, turn right, and telling you how much you should turn left and how much you should turn right. So it's quite easy to understand also this kind of information provided in this way. The question could be, what if you want to provide more complex, more rich information, for example, the position of the robot with respect to the human user using, I don't know, position information or skin stretch information. Is it really useful? Is it easy to understand? And so on. So we never went too much towards this line of research. Now we only use this, let's say, very simple type of haptic sensation because it was the easiest to understand, the easiest to implement, and the one that also really enabled to have two bracelets, wireless, working for hours without any issues of power supply or batteries and so on. So I believe that the solution was really simple, in the sense that really provided the right information at the right moment with the minimum number and the minimal complexity that a device can achieve. So it follows a bit the idea of minimizing the complexity of devices to really find a good compromise between complexity and value they bring to the application at hand.
Okay, thank you very much for the whole presentation, the whole work that you have been doing. I believe it's great, and I'm sure you will get this habilitation, but I'm also sure you will have a brilliant career further on. Thank you.
Thank you very much.
Thank you, Antonio. So, Domenico, maybe you can give us some secret about Claudio's life in Siena, but of course also what you think about what he has done in our groups in the last 5 years.
Okay, so thanks, Francois. Thanks to all of you for inviting me in this nice opportunity to listen to the work by Claudio, and also to stay with these wonderful colleagues that I will try to meet as soon as possible in person in the next conferences. So let me say something about Claudio, because Claudio was, really a young student when he started to come into this office, actually. And it was really great to interact with him. I have to say that Claudio started working with me, with my group, since he was a student, really a master
the first
student,
year of university.
The very beginning. And he went to the Shanghai Expo with Francesco. Do you remember, Claudio?
Yes.
2010 to present the remote touch idea. So what I have to say about Claudio, I mean, Claudio is very well known in the field. I don't want to spend any additional word on the exceptional quality as a scientist. What I want to say is that he's really a great motivator, was a great motivator. So he put a lot of effort in motivating the group in the lab, a lot of energy around him and around the group. And with this kind of attitude, he was able really to coordinate the groups of people towards a goal, it's a paper, a project, whatever. And I still remember the night where Claudio, we submitted the Wearable proposal. Do you remember? It was a great moment. So he is one of the students who made the story of the lab. So I'm really happy to be here. Now, Francois, regarding the question that you asked me about the work done by Claudio in the years after Sears Lab, I think it's, of course, it's relevant, very relevant. And I want to ask some question to Claudio here, also to discuss a little bit with you about the future of haptics. So you mentioned two kind of different wearable approaches, no? The wearables in the style of like rings, gimbal, and things that we were developing. And the other is the encountered haptics device. That is a sort of wearable in between portable and wearable. But you know, what are the main? Of course, I think that there are a lot of differences that we can talk about. But what is your deep understanding or thinking about the two of them? I don't know. Let's say in 5 years, do you think that will be more used in case haptics will spread a lot because of the metaverse, for example?
Yeah. No, I think what I really like about encounter type haptics, which is a bit the same with the H-Link device, is that the device is there when you need it, and then it gets out of the way when you don't need it. So you can wear it, you can use it, and then you can sit and have a coffee with your colleagues, you can write on your keyboard. With the fingertip devices, this is not possible. So when you put them on, you interact with the remote or virtual reality environment. And then when you finish, you remove them and you do something else. So I do believe that in some sense, that depends a bit what we have. If we have some devices that you use only during the application, then we can go also for the fingertip type devices, let's say, that always contact all your hand, impairing any other action. On the other hand, if we think that the future is something that you will always wear onto your body, and whenever necessary, it come up and provide you with a tangible sensation, then of course, the second family of devices is more promising. Imagine having kind of a backpack, or maybe not even a backpack, you have even in your clothes, and whenever you need, it takes out a tangible object for you to interact with, only when you need it. Yeah, depends a bit what we see for the future. I would say that probably the kind of technology that is there only when you need it could be a good approach for really seamless interaction, so that you interact with it when you need, and as soon as you have to do something else, it's not there anymore.
Thank you. So the other question, this is not a question, it's more a discussion, is that I really like the navigation aspect of your research that we were starting doing here, also with you, of course, in Siena, because I think that you know, if you think to my hours in a day, so for sure I use the hands a lot because of typing, but in terms of manipulation of object, is much less time than navigating in the building or across the street. So probably, if I think of my life, I spend more time to go here or there more than you know, opening the bottle or doing something in terms of manipulation. So I think that pushing haptics into the direction of guidance, motion, the example that you were giving us before, would be a nice way to enlarge the spread of a possible application that if I just limitate opening and closing a bottle or whatever, is not as frequent. I really think that using the haptics in a non-realistic way in terms of touching objects can be a way of spread the use of haptics in our community. What do you think in this respect, Claude? Do you have some other comment?
Yeah, no, for sure, navigation is also very important, and so of course the best would be to have like an interface that it's ready there to provide you with this navigation information, and when you don't need it, of course, it's not there. So imagine you could have a set of vibrating motors embedded in your clothes that can help you, for example, navigate areas that you don't know. But there are already some examples, because imagine on Google Maps, for example, it is possible to set it up in a way that it provides you different types of vibrations when navigating with Google Maps if you have to go left and right. So this is a bit of a really interesting haptic approach on how to use this technology for navigation. Of course, navigation depends many things. It's not only moving with your foot here, to go left or right. Could also be to guide a kind of motion for rehabilitation purposes, for example. Can be so. In that case, of course, you need way more than your phone vibrating in two different ways. So again, it depends on the specific task at hand. But if you could achieve a technology that seamlessly could be embedded in all your clothes, so there is a lot of research on embedding vibration motors in your clothes. So if you could achieve really something that is seamless, comfortable to wear, and able to provide a lot of wide range of information throughout your day, whenever you have to go and move to find a new building that you don't know where it is, or you need to carry out some physical exercises, or you need to do something else, of course it would be a great advancement. And in this respect, we should probably go beyond vibrations, because again, we use a lot of vibration because it's very simple. It costs nothing, and also the power requirements are very low with respect to other type of technologies needed to provide other types of haptic sensations. But of course, if you could be able to, again, advance the technology to seamlessly embed other type of actuators to provide skin stretch, pressure onto our body in a distributed form, of course, we could extend our applications of this technology to a much broader range of areas.
Nice, thank you, Claudio. Well, the other argument, the last argument that I want to touch with you in this discussion is, I'm in love with less is more that you presented before, no? And so less is more is really interesting because simplifies a lot the device and makes us happier in using more robust technology and these kind of. But so I have a practical question that is, I also like the experience that you presented at the beginning, where you were changing the compliance of a passive object by applying the skin stretch with the ring. So did you try with vibrations to do the same experience or not? Maybe I missed some part.
Yeah. No, I think in that case we only used the H-ring, so either pressure or a skin stretch. So we didn't try with vibration in this case, simply because, again, so from my experience, what I thought is that if I have to change the stiffness, I should try to compress the or to decompress the fingertip at the right moment if I want an object to feel less stiff than it really is. But of course, there are a lot of things that we can try in this respect. And less is more is a nice concept also because, like when we started, it was a bit a necessity. It was a necessity. I remember, so I like to say this, I remember that Francesco, a colleague of Siena, so we didn't have a 3D printer. So he was using, he bought like a cube of plastic and he was shaping it using a Dremel, so by hand. So it was his own 3D printer, right? And then of course, we started at the beginning in this way to design simple devices because also this is what we knew to do. And then we found out that they worked very well. So they worked very well, and then we got even better at mechanical design. And so at the end, we really published and prepared and designed a wide range of devices that have worked well in a lot of applications, even in medical palpation, which is somehow amazing, I would say. So I would say that in this case, with respect to wearable, to the design of haptic interfaces, less is more is really my motto and something that I really saw and touched with my hands. So you can say the fact that it is.
Yeah, but if you think to what Abderrahman also said before, So if we make a comparison with respect to the vision, so the visual display now are not going in that direction. So if you think about the technology for display are going, so much is more, not less is more. So they are going 4K, 5K, I don't know how many K we can add to the display. So is it something, so it seems that if we want to go towards realism of the interaction, then we need to be much is more, because we want to go, and also I want to touch this point with you, because there is much is more is probably the direction, the globe of Facebook, for example, no? That is very rich. It's not, so they are going into the direction of having as much as possible realistic interaction. And, the other side, if we want to go towards guidance, simplicity of the feedback is the way to go. What do you think?
Yeah. So this is true. I think.
And then I close my questions. Do you think that the glove by Facebook will, just help us as community? So will open to new opportunities in terms of application? Will heal all our ideas in terms of device development? What do you think?
So for the first part of the question, of course, I would say that if technology allows us to do more, more is better. But I would say that, so when we say less is more, I say that there is a compromise. So I think we can still achieve a lot with very, very, very simple devices. So it is important to find the sweet spot, the compromise between complexity and value. But in general, if the complexity does not increase as much because the technology at some point in the future will enable us to design very, very small, very, very compact devices, why not adding complexity in respect to this sense, because the complexity does not result in heavier, larger devices. And of course, in general, it is true that if you provide more haptic sensations, it leads to a better performance. But the increase in the performance, it is very often, at least as of today, it does not justify the increase in complexity, price, and whatnot of the haptic devices. So what we have to add nowadays to achieve that very small increase in performance. And I do believe that the push of big companies in haptics is really, really useful for the community, because first it shows that haptics is there. Haptics is alive, haptics is important for interacting in all these fields. And plus it puts, of course, a lot of funds, a lot of money in the process. And by seeing that these companies are interested in these topics, many more companies will also understand of the importance of providing these haptic feedback in these applications. And this will result, of course, in better technology, more applications, more haptic-ready applications, more devices, and also we'll also see a bit of return, of course, as a scientific community, with more people coming to our conferences, publishing in our journals, and at large, in general, working on the field, advancing the state of the field, the state of the art in this field.
Thank you very much, Claudio, for your presentation and discussion, and good luck for your wonderful future career.
Thank you very much.
Thank you, Domenico.
Thank you.
So it's my turn. So I will start with 2 points I would like to discuss with you, and then I will give you my comments. So the first one, and I think you will not be surprised, you discuss, I would like to speak about the other senses and the other modalities. You speak a little bit with Antonio and Marcia about vision. You didn't mention at all audio, while probably one day with deep learning and so on, speech recognition will really work well. So, and of course, natural interaction between humans is mainly based on on gaze, vision, also on audio, and of course also on haptics. But clearly the complementarity of the modalities is a very important point. And I would like to know if you want to work more on the other modality in your future, or how it will be difficult because you need to be expert in a lot of fields. You are already. So what do you think about that?
I think it's important. So we are working already a lot on, let's say, providing visual feedback when we interact with through haptic interfaces. And it's true that we, for example, we almost never consider audio sensation. But it is important because every time that we interact with something is always a composite interaction. So there is haptic, there is vision, there is audio. So every time that we remove some part of this interaction, this interaction feels less natural because, of course, it's far from what we are used to experience in our everyday life. So it is important, and why not smell? You know, like we tried to work also in the past about smell as well. So I think the concept in general of multisensory experience is very, very, very important. And this is also a bit the objective, although within haptics, of the HReality project, that is combining non-contact media haptics with contact haptics. You know, trying also, because also within haptics you have different sensations. You have pressure, you have skin stretch, you have thermal, and so on. So the objective would be to have a fully multisensory, comprehensive experience. But for this, again, you need a lot of devices, complex systems. So also there, what we usually do is try to understand what is most salient, what is most important for our application, and then we focus on developing those aspects. And it is true that very often audio gets a bit forgotten. Although we have a bit, so we are now, for example, building with Guillaume a series of demos around ultrasound media haptics that also include a good haptic sensations, because we want to really try to move towards a more multisensory, holistic approach to interactions. But yes, it's mostly, again, in my opinion, very often a technological problem, because we also need a lot of a good setup to do everything. Little by little, I think that this is something that we'll need to face, in the sense that it's something that some people realize that is very important. But technologically, if you think of smell, having a smell delivering device, scent delivering device, it's something that it's not easy.
Okay. I would like to see that before I retire. So you have some time, but you have to start on that. The second point is about in your presentation. It was very impressive from a technological point of view, and also application, the spectrum of application you applied. But I would say less about the methodological one. Of course, you have to make some choices. So my question would be, what is hard? Clearly, you need creativity, which is very highly impressive. But I'm sure there are some hard methodological points, especially in control. You didn't show one device you made with Catherine with cable system, and I can imagine how difficult it is to control that. So could you speak a little bit about what is hard, and especially in the methodological
rendering problems. So I didn't speak about it because usually it works a bit less in a presentation. But it's true that, for example, the rendering algorithms that we use for cutaneous sensations, an example is the palpation with Cutaneous, that was, for example, data-driven only. Exactly for that reason, because in that case we had a very complex sensor palpating a soft tissue phantom, and then you have this device with the cables. So it was very hard to find an analytic approach to link the sensations sensed by the sensor towards the actuation to give to the motor. And so we use, for example, a data-driven approach, which is close to what today you will call it machine learning and artificial intelligence. And so there is all that part on, of course, for example, on personalizing haptics. So we are working more and more on designing personalized haptic interfaces for you, both from the hardware point of view and a software point of view. So you give, for example, the the size of your fingertip, and an autonomous algorithm tries to understand what is the best design of device for you to optimize the workspace, the manipulability, and minimize encumbrance and weight of the device. And also personalized haptics in the sense that you have one device, but I want to adapt the rendering algorithm for you, because you have a specific fingertip, which is, so the size of the fingertip among people change very much. You also have a different perception. So we know that younger people have a better perception than older people, for example. So also this, we are working more and more on the rendering aspects. And in those rendering aspects, there is a lot more of the methodological issues and problems that you are mentioning. Especially understanding very often how to manage all these, there is a lot of data. You have a lot of data, a lot of sensing data coming from the sensors, and depending on the device that you use, you can have one or more motors to actuate. Now the problem is that every motor is different. So it is very hard to reach something that works in a wide range of, to drive a wide range of haptic interfaces. And then last, I would like to mention the problems related to the control of robotic systems, so stability issues. So something that I didn't mention at all, but one of the great benefit of cutaneous haptics is that it enables to provide haptic sensations in robotic tool operation in a completely safe way. And this is something that I did especially in my PhD studies. And also there, it is interesting to understand, for example, how to mix between kinesthetic feedback and cutaneous feedback to reach the best performance while always guaranteeing the safety of the system. We did a very nice work with Domenico and Gianni Bianchini on providing kinesthetic sensations, and then as soon as we identified a risk for the stability of the system, remove it, or let's say lower it, and then compensate it through cutaneous haptic to try to see how it would improve with respect to standard approaches that simply remove haptic feedback whenever there is a risk of instability.
Okay, thank you. Thank you. And to end, so I would like to give you some comments, short comments.
Of course.
So you arrived in the lab 5 years ago. In fact, Paolo did know you, but he was...
I met him once at the soutenance of Marco Agravi.
Okay.
So you see, the world is very small.
So he told me, oh, Claudio could be an excellent candidate for you, for the group, and I usually I'm very confident in Paolo's comment. So I was very happy to support your application. I would say 5 years later, I see that you collaborated inside the group with Paolo, Easy, Alexandre, Julien, Maud, Marie. So
we have a student now with Eric.
And Eric also. Okay, so so clearly you are the permanent people who collaborate the most with the other people in the group, and it is really incredible. And of course, you collaborate also with people with hybrid, with mimetic. You have a collaboration also with IETR. So it's really incredible. Maybe you did already more collaboration than myself during all my career. So I am really impressed. So really you are a crucial people in the group, and so that's great. So clearly, I think we can be proud that you are in our group as a CNRS colleague. So I have to say that as an INRIA people, I am sad that INRIA never gives you the opportunity that you would be an INRIA colleague. So Stefan was in the INRIA jury, but as you know, hopefully Claudio has been recruited at CNRS, which is very good. Probably, certainly, Claudio would, if you had the opportunity for both, probably you would have chosen CNRS. I would say it's good for the lab for the reason. But I have to say that I'm sad for that, to be honest. Then
he was ranked #1 by the committee.
alors to say everything, yes, but it was the first committee, the admissibility committee.
Okay.
And in
So,
fact,
sorry,
after
François.
that,
Yes.
there has been the CNRS results, and that's it. Okay. And the last, I was thinking about what is your weak point, and it was difficult. I don't know if in the jury some people is able to tell what is your weak point, and I've been able to find one related to the huge number of collaboration you have. So in fact, I've seen in your publication list that you have only one paper with only 2 authors, with Filippo Sanfilippo. I would say it's logical at this step because you are not allowed to supervise alone any PhD students. But I would say my advice would be, I think it is important for you to do sometimes research alone or only with a single student, so that nobody in the community could say, well, maybe what is really your contribution with respect to the other authors? I would say for people around this table, it is clear and outside. But sometimes in some jury, when you will think about application as a senior researcher, typically, maybe some very bad people could mention something about that. So, and even for you, I think it would be good. So it would be my advice. That's all for me. So now we will have to go to the internal discussion. So I will move in another room. I propose we have a 5 minutes break, and then all the jury members we meet using the Zoom link I sent you yesterday. Okay?
And for the YouTube, we can put back this.
And then after we will come back.
And then we can put it back when we come back. Okay? So it's
because there are so few to discuss. You gave an excellent presentation about your research on cutaneous and wearable haptics. You did a very good choice in presenting mainly the design of the devices and the numerous application that you have considered. And it was also a good choice to focus on some specific contributions that you had. That was great. The discussion shows that clearly you are a mature researcher, very honest. You are able to speak about the limit of the field, and that's not so usual. You are clearly a world expert in your field, which is not a very broad field. It is really the field where you are the expert, and you are really one of the world experts in your field. All the jury, which is composed of some famous researchers, all the jury was really impressed by your career in terms of publications, in terms of internal and external collaborations, in terms of awards, in terms of supervision, in terms of services for the community. In the report, there are some words that consider you as an extraordinary researcher, exceptional researcher, and there was no people in the jury that disagree about this word for you. So, of course, we are all unanimous in awarding you the habilitation à diriger des recherches de l'Université de Rennes. Congratulations, Claudio. It's a real pleasure for me.
Thank you very much. Thank you everyone for being here, and to the committee, to Francois, and I hope to see you all soon, very soon in person. And thank you again for being here, and I'm sure we'll have the chance of talking more about haptics together in the next months. Thank you very much.
Perfect. So thank you all.
Thank you very much. Know what you're seeing.
Bye.
Yeah.
Have a
nice weekend.
Thank you.
Thank you very much.
Thanks to all of you. Bye.